Now let's review, because some of you need to pass this thing. So we would want to make sure we can get enough of it to pass. Huh? But if you pass the class, so it doesn't matter. But you got to be 70 on the exam. Okay? All right, so I'm on the review sheet that doesn't have a number 2. We have one that's number 1 and one that's number 2. Now let's go and wrap it up. Sophia, the quiz is over. We need to wrap it up. All right, so here we go. The review sheet. Any problem on the entire review sheet? So I don't know if you looked through, how far you got, what question do you have? Raise your hand if you have a question during this mumble. Victory? What? So 1B? Okay, yep, 1B. All right, let's look at 1B. It says simplify as much as possible. Okay, so who remembers what we do with something like this? Yeah, change them all into sines and cosines. So cosine's already cosine. I like to put them over 1, but you don't have to do that. Note, secant is 1 over cosine, so this will be 1 over cosine squared. That's what secant is. Connor?
Are you going to give us these forms?
No, not these. Not these basic ones. You need to know what tangent is.
Tangent, sine over cosine?
It is sine over cosine. That's exactly what it is. And then sine is just sine. Now what do? We changed everything into sines and cosines.
You just have to solve.
Now stuff should cancel, right? So those guys cancel.
So it's just, wouldn't it just be sine squared over cosine squared?
Yep. And that is tangent squared. Very, very good. Sine squared over cosine squared, and that is tangent squared. Super. Super. All right, what else did you find as you were looking through your review? What?
Number 3, the first one.
Problem number 3?
Yes.
All right, when I look at this, this actually ties in directly with our limits. Because the first question you have to ask yourself is, is this growth or decay? Are these numbers getting bigger or getting smaller? And I want you to look at this guy right here. He's less than 1. What happens when if you found the limit of that? What would the limit of this thing be? 0, which means the terms must be getting smaller. And if they're getting smaller, then this would be a decay problem. So this is a decay problem. If that number's bigger than 1, it is a growth problem. Now, what is the percent growth or decay? So we figured out that this is decaying. These numbers, if we started, typing things in, it would be getting littler. If this number is less than 1, we decay. The amount that it's less than 1 by is the percent of decay. So how much is this less than 1? 27. So this is a 27% decay. Notice, I'm not doing any math here. I'm just going to know what's going on. Whatever this amount is less than 1 is the percent of decay. Whatever the amount is greater than 1 would be the percent of growth. Okay? And then the last question there, the last part of that is, what is the initial value?
300.
300. This guy is the initial value.
Oh, so this you just don't need to really have that.
You don't need any math. You know what's going on. Right. Right. So this is one that if you just study, you'll be set on that problem. Right? All right, well, that calls me.
What percent of the final
20% is the. What do you mean, extra credit opportunities? No. Every day you come in for office hours. You can study, you can prepare. That's it. Oh. Okay. I'm just not good at math. And so let me just tell you, I'm not good at bench press, okay? And how do you think Cody reacts when I say, oh, I'm just no good at this? What do you think he says to me?
Do it.
He says, do it anyway, and the more you practice, the better you get. So there is no such thing as, I'm not good at math. There's such a thing as, math is hard for me, and I'm too lazy to practice. That happens.
I mean, I'm making a bench press too.
But no excuse.
What's your
No
max?
excuse. Before I had cancer, I could bench press my body weight.
Really?
Since I've been in treatment, or since I had treatment, and I can only, my highest is, my very highest is 100, but I only managed that one time, and I haven't done it for a long time, so, yeah, I'm terrible. I'm terrible. But I must tell you that when I went in for my 6 month, after my bone marrow transplant, I had to go in for a 6 month checkup. And they said, oh, everything looks great. We think you can go back to work part-time. Well, I've been working for 4 months full-time. So. And they said, well, how do you feel? And I said, well, frankly, I feel great. Everything is the same except my bench press. And the doctor looks at this 60-year-old woman and says, bench press. All right, what else?
You have free time, but I don't.
What else have you found that we need to review?
You do A,
1A, that is an exponent simplification problem. And the nice thing about these is, there's no particular order you have to do stuff, you just have to do everything that needs done. So when you look at the problem, you should see something that needs done. What do you notice about the problem? Okay, so Brendan notices, and again, this is personal choice, how you start. He spoke up, so I'm gonna do what he said. He said, inside the parentheses, I have a negative thing here and a negative thing here. So when things are negative exponents, we have to move them. So the 3y to the 7th will stay put, the 5x will stay put. But this y to the 4th is going to the top, and this x squared is coming down.
Why wouldn't you add them?
So one thing that has to happen at some point in the problem is you have to take care of your negative exponents. So you don't have to do it first, but you have to do it. Now, of course, Brendan is still talking. So he said, why don't you just do some combining here? Well, I can. Y to the 7th and y to the 4th would be y to the 11th. Oops. And x to the 1st and x squared would be x to the 3rd. So another thing that needs to be done is, if you have x's and y's that you can put together, you want to put them together. That can be done at the end, that can be done at the beginning, whatever works for you. All right, now, what about this? There's still something that needs to be done. You have a -2 on the whole fraction.
Yeah.
What does a negative number on a whole fraction do to the fraction? Flips it. So this becomes 5x cubed over 3y to the 11th, and then it's just a +2. Now, kids, if you take everything in here to the -2nd power, you see how every exponent will be negative, and that will just make everything change? So we just do it all at once. Flip the whole thing over. Now, square it all, we get 25, 5 squared, that's square to 5. 25x to the 6th over 9y to the 22nd. remember, when you have x to two exponents, they get multiplied. But when you have two x's, the exponents get added. So here I added the 1 and the 2, here I multiplied the 3 and the 2. Alright, another one. What's another one? We got time for a few more. Let's get them in. What else do we need to review? 2a says, what's the cosine of 120? So cosine 120. First thing I'm going to do is draw 120 degrees. Now remember, when we draw our angles in trigonometry, they always start here. They go this way. So that's 90. This is 180. So 120 is somewhere between 90 and 180. How big is this guy right here? This is the important angle right here where the finger is. How big is he? 60. So I have a 30, 60, 90 triangle. If you're doing this without a calculator, you have to have a special triangle. So it's going to be 30, 60, 90, or 45, 45, 90. What do you know about the sides of a 30, 60, 90 triangle? The short side is 1, the long side is √3, and the hypotenuse is 2. I don't know how you remember that. Across from the √3 is the 60. Anything negative, we got to worry about that too. Anything negative in this problem? Oh yeah, the 1 is negative. Because here's the origin, folks. Aren't we going left? And left is negative. All right, cosine. What's cosine? SOHCAHTOA. Cosine is adjacent over hypotenuse, which will be negative 1/2. Adjacent over hypotenuse. You can also think of it as x over r, so it's the x side over the radius. Yeah, the big circle. Cosine is both things. All right, who else found something? Doesn't have to be from the first page, although it can be.
2b.
2b says find the tangent of pi. Well, this is exactly the same kind of problem we just did, except pi is a radian measure. How many degrees is pi? The decimal for pi is 3.14, but how many degrees is pi radians? 180. So this is the tangent of 180 degrees. So I'll draw a nice circle. Oh, actually, I'm giving it away. Where's 180? 180 is over here, isn't it? Remember when your angle is on an axis. This one wasn't. 120 kind of jets out, but when your angle is on an axis, you have to draw your picture. Right? So this is the point -1, 0. If the radius is 1, we always make our radius 1. Tangent is y over x. So that would be 0 over -1, which is 0. The tangent of 180 is 0. All right, one more. We can do one more.
2c.
2c is the cosecant of 5 pi over 3. So what's the first thing I would Connor?
5, 180.
Yep, divided by 3, so that'll be 300. So I'm going to draw 300 degrees, which would be all the way around like this.
And then you have to change the degrees in
Already did that.
the
300. No, this is a no calculator problem.
R.
I'm not doing my calculator. So how big is is this angle? This is just like the first one we did. How big is that angle right there? How big is it? 60. It's gotta be 60, guys. There's no formula for that. You just gotta be thinking. All the way around is 300, right? 360. All the way around is 360. If I went 300, then I've got 60 to go. That's the same triangle I had over there. So I got a root 3, a 1, and a 2. That's my 30, 60, 90 triangle. Never changes. Never. Always the same. Anything negative in that one. The 2 is never negative. The hypotenuse is never negative. What's negative? The root 3, y, going down. So cosecant is reciprocal of sine. So this is going to be 2 over negative root 3. Hypotenuse over opposite, which is negative 2 root 3 over 3 when you rationalize it. All right, for next time, this sheet that we've been working on, I want you all to find 10 problems on this sheet, one you're working on. Find 10 problems that you need to review. Find 10 problems that you have a question about. Thank you.